Hi, welcome back to the Introduction to Python Programming course. This is section 10, class objects. We're starting to move into some more complicated concepts, but hang in there. We're going to go over some exercises, provide some solutions, and we're also going to review all the previous sections that we went over. In fact, the next section is actually going to be a review section with more questions and answers related to the previous sections to really help make sure that we're ironing out these concepts. With that said, let's go ahead and start discussing class objects. The lesson objectives for this video include understanding the following: definition and initialization, attributes and methods, self and inheritance, magic methods, and composition. Okay, so this section definitely has a few concepts to go over. And then of course, the last bullet is the commit, and that's related to the Git version control project that we're using. We're going to use that number in the lab to get a hold of the resources relevant to this lesson, which of course is the cheat sheet and then the questions and answers and the examples. So definition and initialization. Define and initialize your objects. The class keyword. Use the class keyword to define a custom object, a custom data object. In the example, we can see that we're defining a class shape that has a height and a width, which are called class attributes, and a class method called area. Now, what is a class method? Well, it's a function. However, this function just belongs to a class, and we call it a class method. You also see that self keyword. In some other programming languages, you might see the keyword this, but in Python, it's self, and self is a reference to itself. So it's going to use its own height attribute, which would be 52, and its own width attribute, which would be 48 in this example. And of course, if we didn't define those, then when we try to run the area function, it would return an error because it wouldn't know what those are. So those have to be defined. So why create objects? Well, custom data objects allow you to organize your code into reusable objects with complex concepts behind them. So we can organize data into a form that defines shape. We can name that object shape, and then we can have attributes and methods that provide the concept and operations related to a shape object. And now we're starting to discuss object-oriented programming. Initialization. Call the name of the class object and assign it to a variable. So you can see on line 9, we have test equals shape with the rounded brackets. That's important. Don't forget the rounded brackets. And then the line 10 is just printing the area of that shape instance via the test variable. Remember, the variable points to the data object. The variable is not the data object. All right, let's keep moving. Attributes and methods. Customize your object. Object attributes. Simple variables within class definitions are known as class attributes. For example, self.width equals 52. And in this example, we see the proper way to initialize class attributes within the Python programming language. You don't want to do it the way it was shown in the previous slide. You want to do it this way, which is to use the init function. The init function is a special function that runs when you instantiate or create a class. So when we run that line 10, that init function runs automatically and creates those class attributes. So this function is creating those class attributes in the same way the previous slide was creating them without actually running that function. Now, in some other programming languages, that would be called a constructor. So within that constructor, it runs when the class is first created and those attributes are created. And then those attributes are related to the to that shape instance, and we access those through the self keyword. Object methods. Create custom functions within the class definition. You must pass self as an argument. So we have to pass that self keyword. That's part of the definition process, and that gives the method access to the attributes of self. You must pass self as an argument. The method has built-in access to class parameters and methods via the self keyword. Okay. Special methods. Init is a special method that runs when an object is created. Other special functions with specific purposes exist, and we will discuss some of them. And of course, we will go over some of them when we use them. Self and inheritance. Dry. Don't repeat yourself. So a lot of these more complex concepts are actually ways to implement dry. So the class object is a way for us to, not repeat ourselves by organizing our code in a way that cuts down on how much code we have to write. The same thing with inheritance. It's a way for us to organize our code in a way that we don't have to keep writing additional code. Now, the self keyword is critical to the correct implementation of a class object. We know that. We discussed that in the previous slides. Inheritance. Avoid duplicating code and copy code from a parent class. This is again an organizational concept that promotes the drive principle. Triangle inherits code from shape while providing its own version of area. So if we look at the class definition of shape, we can see that it has a width and a height. Those are the class attributes. And then it has a class method called area, and it returns a calculation of that is the area. And then we have class triangle, and then in the rounded brackets, we have shape. That's how we tell Python, hey, you need to inherit the code from this class, which is the shape class. So by inheriting it, it gets access to the width and the height. Those get defined the same way. And it also gets the area function or the area method. However, because triangle has its own way of calculating the area related to the triangle shape, we have to override that area method and provide a new definition. And inheritance allows us to do that. So we copy all the code over into triangle, but then we provide the necessary changes that make triangle different. And that cuts down on the code that we need to implement. For example, if we didn't use inheritance, we would have to put the init function in the triangle class, and we would have to put its own width and height, and we'd be duplicating code. And then if we did that for, let's say, 10 shapes, and then later on we need to make a change to all the shapes, that'd be 10 different classes we need to change. Be easy to accidentally forget one or make a typo in one and then cause bugs in the program. And of course, when you have a large program, like take Firefox, for example, over 1 million lines of code, that kind of programming can create problems, lots of problems. So inheritance, avoid duplicating code. We already discussed that one. Polymorphism. Python has a loose implementation of polymorphism, works with inheritance to apply the same operation to different objects. So what is that a reference to? That's a reference to overriding certain attributes. For example, triangle has its own version of area, shape has its own version of area. It's polymorphism, taking many forms. So those many forms is different versions of area. Okay. Composition and magic methods. Is it magic? Well, let's take a look. Composition. Class objects may contain other class objects. Such designs should build a complete object. A car has a tire. Perhaps a car class contains another class tire. And magic methods. Special methods that allow us to manipulate how certain operations occur. The __EQ__, which is referring to equality method, allows us to define how equality is tested between two objects of the same type. So if we look over in the example, we can see we have a class arm, a class leg, and then a class robot that is comprised of a left arm, a right arm, which are both the arm class, and a left leg and a right leg, which is both the leg class. Now again, these are just examples, so they're much shorter than they would be in a real program. And then, so that's a representation of composition. We're building a class off of other classes. And then we have another special method, the _EQ_ method. This allows us to define how equality is treated. So if you take a look at line 27, where we print we print the result of test being equal to test2, Python wouldn't know how to compare these two custom objects unless we provided a definition for that equality method. So in a lot of instances, if you want to compare two custom objects, you're going to have to implement that equality function to properly compare those objects. So let's jump into the lab environment and take a look at some of this code and some of the questions and answers related to this concept. All right, here we are in the lab environment. I'm going to go ahead and right click. I'm going to git bash here. I'm going to go ahead and do a git reset hard just in case there's some changes in the directory. I don't want to be concerned with that. All right, and then I'm going to go ahead and check out the new commit, which is, let's see, what is it? C8 6752. All right. Section 9. Head is now at section 10. Okay, there we go. I'm going to go ahead and go into that section. We'll take a quick look at the cheat sheet. All right, be sure to take a look at that. That has additional information on there. That's really good. And now I'm going to take a look at the examples. Let's take a look at an example. Example 1 first. Here we are, example 1. I'm going to go ahead and run that. 2496. That sounds reasonable. All right, let's go ahead and open up another example. Look at example 2. All right, going to run example 2. 2496. Okay. Let's take a look at example 3. Let's see, what is this wrong here? Expected 2 lines, found 1. Okay, so it wants us to do that. Let's go ahead and run that. Make sure that runs. 30. So you can see we're creating a triangle here, and then we're calling the area method. And the triangle inherits code from the shape class. Now what happens if I get rid of this area definition? Okay, let's see what happens. I think I need to put pass here. Pass is a special keyword that just tells Python, I don't have anything to put here, go ahead and pass over it. So this is not something you would normally do, because normally if you're creating a class that inherits from another class, you're going to be doing something different there. Let's go ahead and run this and see what happens. So we get 60, and that's 10 times 6. That's because we're using the area definition up here, because we no longer have a triangle definition of that area. So if we go ahead and undo that, now triangle has its own area definition, and we run, we're back to what we had before. And the reason that works is because of inheritance. We copy all the code from the shape, and we make triangle just automatically have that code, and then we can make alterations to the specific areas of that class that we need to. Let's see, do we have an example 4? Yeah, let's see what's in example 4. Okay, this is the robot. So let's see what happens when we run this. So it's saying they are true. So we can see that the equality test is just testing the length of the arm, which will be true because they're both going to get a setting of 40. So 40 is going to be equal to 40. But I don't test anything else in the equality check. So it's not accounting for the other arms or the legs. So when you write your own equality test, you'll want to make sure that with relation to the class object that you're implementing, that makes sense for what you're doing. All right. And then here you can kind of see how I go to the different attributes. So I have a test which is equal to robot up here. It has a left arm, which is this, and that arm has a length, which is up here. So that's pretty cool how we can define attributes and reach into our objects with those various methods and attributes. All right, let's take a look at the questions and go over the answers for those questions. So we have exercises, section 10 questions. So task 1, we're going to start off easy. What are class objects? Why use them? Task 2, we're going to notch up the difficulty a little bit. We're going to create a class circle that inherits from the shape class that was shown in the lesson. Implement the area class method that returns its own area calculation. The area of a circle is shown below. So pi times radius to the second power. And I wrote in what that would look like in Python code, which would be 3.14 times 0.5 times width. Because remember, we're going to have the width, which would be the diameter, and the radius would be half the width, if that makes sense. And of course, if you have a question on the area of a circle, it's really easy. Just go to Google, say area of a circle, and you can look at this calculation too. Also, I bet if you did this, you'd get a pretty good area of a circle Python. Let's see what it shows there. It's going a little bit deeper than we want to go, but you should be able to just do this calculation and get the correct answer. And then task 3, create an animal class with 2 attributes, height and weight. Create a method called speak. Return the string bark. Create another class cat and inherit animal. Create a cat object and call print on the speak method. What happens? How would you correct this? All right, so pause the video, read the questions, and attempt to answer them, because we're going to go over this in 3, 2, 1. All right, let's go ahead and go over the answers and see what those look like. I hope you got them right. Again, you don't have to come up with the exact same answer as long as you get the right answer. For example, as long as you get the right area of a circle, that's completely fine. All right, so let's get that open. Let's go to the answers. Task 1 answer. Class objects allow for code organization centered around complex concepts. Use class objects to better organize code and practice the DRY principle, which is don't repeat yourself. Task 2 answer. Okay, we can see we have a class circle that's inheriting from shape. We're going to go ahead and assume that that's the shape from the lesson, because that's what it's supposed to be. All right, it looks like I did pi out to a larger decimal place. You don't have to do that. If you did just 3.14, that's perfectly fine. And then we have an area method, which would override the shape method. So that's I put the radius equal to self dot width times 0.5, which would cut the width in half, which would give us the radius. And then to take radius to the second power, I did radius times radius. So a little bit of, I think a little bit of pre-algebra maybe, I think, right there to do the power thing. And then we return self.pi times radius, which gives us the answer we're looking for. All right. And of course, if you use Google to look up and assist with getting the answer, that's perfectly fine. Lots of programmers and developers do the exact same thing. And that's almost, that's a normal part of the process, to go out there looking for how people have solved it and then applying it in your own programs. Now, hopefully you didn't just copy and paste an answer because you're in the process of learning, but you'll definitely want to spend time understanding how this is working so that when you implement these answers, you know what's going on. And then task 3 answer. Cat prints out bark because we inherited from animal. To make it print meow, we would give the class its own speak method, which would override the animal's speak method, which is what we would want to do for the cat class, because the cat doesn't bark, it meows. Okay, so that completes this task. Let's head back over to the slideshow and finish out the lesson. All right, composition and magic methods. We already went over this, so I'm going to the next slide, which is the section conclusion. What we learned about class objects, attributes and methods, composition and inheritance, polymorphism and magic methods. I hope you enjoyed this lesson, and I hope to see you in the next. Thank you.